Hi, guys. Today we're going to go for a little bit of a turn and do something a little different. We're going to be learning how to divide polynomials. It's all going to connect together by the end of the chapter. So it might seem a little bit segmented right now, but I promise you it's all related. Now, the book is going to teach you how to divide using long division. And if you look at Delta Math, it's also going to teach you how to divide using long division. I'm going to be honest, long division is super confusing. The subtracting, it's really confusing. So I'm going to teach you a different method. And I'd like you to try this method, see if it makes sense, see if you understand it. And then, worst case scenario, you can ask me to teach you long division later. But we're going to use the box method to divide polynomials because you know what? Dividing is just backwards multiplication, and the box method is for multiplying. So the first thing I want to talk about is, if you have a division problem, so here's just a sample, really simple division problem. So you have your divisor on the top, your dividend on the bottom, and then the quotient is the answer. And so something divided by something else, and it gives you an answer. We could rewrite this if we wanted to as a multiplication problem. So if we were to rewrite this, you would take the bottom of the fraction, 2, you would multiply it by the answer, and that should give you the top of the fraction, okay? The thing you're dividing by times the answer gives you the top. That's going to be very important for what we're doing today. And what we're doing today is, again, the box method. So I'm going to rewrite this again as the box method, just so that we can see where everything kind of goes. So again, the thing you're dividing by goes along the left side. The thing that you are dividing goes inside the box, remember, because that was the answer to the multiplication problem. And then the answer to the division problem is going to go across the top. So remember how the box works is you multiply the left side times the top, and it gives you the inside. We're just rearranging it a little bit. So today, we're going to be given one of the multiplication parts. We're going to be given what should be on the inside of the box. And then our goal is to figure out what goes on top of the box. And that's going to be our final answer. So let's try a problem. So here's my original division problem, 3x to the third plus x squared minus 4x. And I'm dividing it by x minus 1. To help us out a little bit, I am going to rewrite it as a multiplication problem so that we understand where all the pieces go in the box. So as a multiplication problem, x minus 1 is going to be multiplied by something, and then we want it to turn into the 3x to the third plus x squared minus 4x. All right, so I'm going to go ahead and start building my box. Now, sometimes we might not build the right size box, so I'm going to make 2 along the left side because of the x minus 1. And since this has 3 terms, I'm going to go ahead and go 3 across the top. That might be too big, it might be too small. It doesn't matter. We'll adjust if we need to. And again, I'm going to put the x minus 1 along the left side. Now, this blue part here, this is what we're supposed to get when we combine together everything that's inside of this box. And so if you remember from the box method, the first part of your answer is usually gotten from this first box right here. So I'm going to take the 3x to the third, and I'm going to go ahead and fill it in this box. So I'm pretty confident that's where it goes. Now, this is like a puzzle. So x times something needs to make 3x to the third. Well, that would be a 3x squared. Now, this 3x squared, it's multiplied by the x, but it's also multiplied by this -1 down here. So I'm going to go ahead and do that right now. 3x squared times -1, and I'm going to put a -3x squared right here. Okay. Now, if you remember again from using the box method earlier this week, along the diagonal, we're going to have some like terms. So if this is an x squared down here, I'm going to expect this box up here also to be an x squared. And those two boxes together have to combine to make my answer. My answer is a positive 1x squared. So the next part of the puzzle is -3 plus what will make a positive 1? And the answer is 4. 4 minus 3 equals 1. So these two combine together to make this one. Okay, very similar to how we got the 3x squared. Now I need to figure out x times what makes 4x squared. So x times 4x makes 4x squared. You know you're doing something right if you're getting descending order across the top of that box. Now this 4x, it gets multiplied with the x, but it also gets multiplied with the negative 1. So I'm going to do 4x times negative 1, and I'm going to put that down here. Now again, this is going to have a like term on the diagonal up here. And those two combined together should make my x term from my answer. Well, guess what? It already is that. It's negative 4x, and that's negative 4x, and I don't have any more terms. That means I'm done. I don't need to do anything else. If I pull everything out of this box, it will turn into this blue number up here, which means that this divided by the x minus 1, it makes this top thing. I'm going to throw a plus sign in there, and this is my final answer, 3x squared plus 4x. Okay? So again, instead of doing long division, today we're going to think of this as reverse multiplication. X minus 1 times what makes the blue numbers? Let's do one more together and make sure we kind of understand where all the pieces of the puzzle fit. So here's my next example. So 2a to the third plus a plus 18, and I want to divide that by a plus 2. Remember, that means I'm trying to figure out a plus 2 times what will get me 2a to the third plus a plus 18. Just like on our last problem, my box, I'm going to make it 2 along the left side because I have a binomial right here. And then I'm just going to start with the preliminary box. I'm going to make it 3 long because this has 3 terms. But honestly, I'm not sure how big the box is supposed to be. We can always, there might be extra squares like the last one had, or we can add on more squares if we need to. And I'm putting the a plus 2 along this side. Okay, first part of the puzzle. The first term from the blue writing is going to go in the first box right here. So I'm going to put the 2a to the third right here. A times 2a squared makes 2a to the third. 2a squared times 2 makes 4a squared. Okay, so again, I put the first term in the first box. I figured out a times what makes this. And then once I figured out what goes up here, I had to multiply it by that as well. It's like distributing. Okay, the box method, the beauty of the box method is that the terms are on the diagonals. So now I'm going to look at this diagonal. 4a squared plus something. When you're working inside the box, you're doing adding. And when you're working on the outside of the box, you're doing multiplying, okay? So a squared plus something, and it's supposed to give me what the answer has. Now, this answer doesn't have an a squared. It's missing. There are no a squares. So I need this 4a squared. I need it to go away. I need it to cancel out. So I need a negative 4a squared. So if you have a missing term, you need these two to cancel out. So I just made it a negative instead. That's because there was no a squared on the top of the fraction, okay? All right, a times negative 4a makes negative 4a squared, right? Descending order. Negative 4a times 2 makes negative 8a. All right, let's keep going. So now negative 8a plus this thing on the diagonal, I don't know what that is yet, and those are going to be added together, and they have to equal this 1a from up here. So the question is negative 8 plus what makes positive 1? Or what minus 8 makes positive 1? That might be an easier way to think of it. And the answer is 9. 9 minus 8 makes a positive 1. So I'm going to put a 9a up here. A times 9 makes 9a. 9 times 2 is 18. All right, now I've ran out of boxes. That doesn't mean I'm done with the problem. Maybe I just didn't draw the box big enough, right? I didn't really know how big to draw the box. So I'm going to keep going with the same pattern that I've been doing. So 18, maybe there's a diagonal box up here that it needs to add with. I don't know. So 18 plus something has to equal the number from the top of the fraction. And it's already equal to 18, so I don't actually need any more boxes. It doesn't need to add with anything. We're good. We've got it. And then remember your final answer is across the top of the box. I'm going to throw in some plus signs. Honestly, a better way to do that would be to do 2a squared minus 4a plus 9. I was just being a little lazy. So that'd be a better way to write your answer. But there it is right across the top. And this is division using the box method. That's the end of our first video.